Video, I would like to discuss the assignment 4. This assignment 4 is for us to practice how to operate on trees, especially on the multi-node trees. So far, we have already learned the binary tree. As we know, the binary tree consists of root nodes and with another nodes, right? And its binary tree consists of root nodes and a subtree, the left subtree rooted by the left child, and the right subtree rooted by right child, right? And in the binary tree, we require every node in this tree. Let's say this is T. And T consists of vertex and the relationship, right? The objects and the relationship. We use V to represent each node, each vertex. Use E to represent the relationship. So we see that for any Vi belong to V, and the adjacent vertex of Vi, the size of this one is smaller than or equal to 2, right? So this is what we talk about. First should be tree, and then this is a binary. And such that when we represent this tree, for each tree node, we have a binary node. And a binary node is a class which holds for data, right? And then so we see this is the BT node. Did you remember? We have the exercise, right? The lab. And then after that, we have the data, right? Let's say this is the element. And this node, it is the smaller container. It's a wrapper. And then also we have left and right. And both, let's make it a little bigger. So both are what? Both are BT node. Right? Okay. And then, so this is what we talk about. The binary tree consists of binary node, and which is the tree structure. And in this study, we check for multi-node trees. So this is the multi-node tree, right? In the multi-node tree, which corresponding to each node, once the tree is enough, we really don't care about how many child nodes it do have, right? It could have 3, it could have 4, it could have 5, right? So this is what we talk about multi-node tree. In this multi-node tree, so we'll be aware of that. In this case, we need to have the node class for each specific tree, right? So take a look. The class we have, we called it is the linked tree. And the linked tree consists of a multi-tree node, right? So let's just say, go back to here, right? So this is the multi-node tree consists with the multi-tree node. Corresponding to for each this guy, right? For each this node, how can you represent this node in our digital world? And which kind of data we would like to hold? And we see all the tree structure, which is a collection of related data. And such that for the tree structure, we have to represent the data it holds, and also at the same time, we have to maintain the relationship, right? So such that the data we need to have, and I wanted to make sure the same name here. So let's take a look at the multi-tree node. And the multi-tree node has been defined somewhere supposed to be somewhere here. I see. And this is supposed in the data structure class. I see. Well, students feel confused. Okay, good. Okay, so this is a go to the specific, this is the multi-tree node, right? Let's say this is the name, it is, now I see. So this is the element, right? And this element hold for any kind of object, any type of a class, right? So here we use a genetic class, and except this one, we also needed to represent. Take a look at this one. Take a look at the class diagram we have here. This is a class diagram. So you can see here it consists element and also consistent children object. And interesting it is these children corresponding to who derived from this tree node, right? And since they could have multiple nodes, we do not have a constraint on the number of children allowed. So in this case, it is used the array list and a hold for the data type, which is the multi. Let's make it bigger. So this is the multi-tree node T, right? So this is the data member we have. And also we just ignore the method part, right? And suppose also the same as the class diagram tell us, it is supposed also have the method. And we just save our time to ignore that. So you can see, now I want to make this one a little bit bigger. Okay, so you can see that what we have learned in class is binary tree. In this assignment, we want to practice on the multi-node tree and look like that, right? So corresponding to this tree structure, we need to have the root. We need to have the root for this tree, and then after that it is, and each is tree linked with another tree node, right? Each this kind of tree node also linked with another tree node. And such that now I can move to here, right? Okay, take a look here, right? So we have a multiple node tree. This consists of multi-tree node, and then so this is a linked tree. This linked tree corresponding to what we talk about multi-node tree, right? And this one consists with, this is same as what we talk about in class. All the tree, we just keep what? We keep the root. And this is the multi-tree node T, right? And such that, and also in another case, it is another thing very common, which is we need to have the sides. In this case, we use a pound sign just to make sure it is, this can be derived, this can be used, can be derived in the, this variable can be used in the derived class, in the child class. They can use that is to go to the object-oriented programming side, right? Okay, so this is the multi-node tree, right? The first should be the tree. It is the connection of related nodes, related objects. And this relationship of how many adjacent, how many related objects is allowed, so there is no constraint. And since there's no constraint compared to before, we have very good, the left and right reference. In this case, we cannot give this specific number of variable used to represent the children's. And so we have to use another connection reference. You can use array list or linked list. Doesn't matter here. Okay, so this is the structure for this multi-node tree class diagram, related information. And now I want to go back to the description here. Okay, so in this description, we set objective, and the student demonstrate ability to work with multi-node tree, where each node can have reference to more than 2 child nodes. And as implementation, each node stored a list of its child nodes in array list. This is a more complex data structure. Students will also demonstrate the ability to code a complex recursive method for traversing up a tree. So this corresponds to how can you use what you have learned from binary tree to walk through in the multi-node tree. So let's see what it is this is a summary. Let's check. In assignment, you will be implement a method for linked tree, a data structure for generic elements held in a tree format. And this is different from binary tree. This is a multi-node tree. So each node can have any number of children nodes. You will also be implementing a method in PyramidScheme.java, which is extension of a linked tree, specifically for person elements. So what corresponding to here, corresponding to in this study, in this application, now I want to use different color. In this study, we want to use the specific application, which is called the pyramid, which is called the pyramid schema. We want to use this multiple tree here, and that is exactly it can be used for that. And they have different nodes, right? Same as before, it allows to have multiple related nodes. In this case, this node here corresponding to person. This is the person. They will hold the person node, right? And this person node, which is the extended person node. This person node, which exactly this one, it is a multi-tree node. It's not a binary tree. It's multi-tree node. It holds the data is a person. Can you see? So this corresponding to this person node and corresponding to it hold the specific object, which is a person object. Can you see? So each this one is a person node. And some allowed for 2, some maybe just 1, and some maybe 5, right? So this is a multi-tree node. Corresponding to there's no limitation on children nodes. Okay? And then so in this case, and what they mention this is a pyramid scheme, this class, which it is one type of the multi-tree node, and which hold the data is a person data, right? Which is extension of linked tree specifically per person elements, include the logic that is representative of real pyramid schema. And this is a specific basic model. And this model, and in some time of the whole history, it was very famous. People in the beginning very like this module, and later they found out this module not so good because it's unfair to the people. Okay, so we want to use this example to show how we can use programming, use data structure to help the people. Okay, in a pyramid scheme, each person tries to recruit people. Those people pay to join, and then try to recruit their own people. So corresponding to this is recruitment. So this person, let's say this is the Trump. Okay? Trump recruit Ru, for example, right? So this is a recruitship, right? Hiring relationship. Okay, so those people pay to join. So such the Ru need to pay to the Trump for the membership fee, and also Ru trying to recruit other people, and other people need to pay to the Ru. The money from those who join trickles up the tree to the person who started the pyramid scheme. The earlier you get in on it, the more money you can make. But this is illegal. And the higher up you are in the scheme, the more legal trouble you will get in. So in the pyramid scheme, each new recruit calls people high up in the tree to earn more money. And then there is a point in the simulation where the whole pyramid scheme collapses. The project can be used to help prove the improperness of the pyramid economic model. Your job in this project is to implement a method, especially specifically in the pyramid scheme, retains the chain of the people who should get a portion of the money when a new recruit is added. So this is a main task. Except the main task, you also need to implement another, missing statement. Okay, so we'll talk about that. The following is a diagram of the pyramid scheme made using the default pyramid. $25 recruit price corresponding to membership, also corresponding to the money you need to pay to who hire you and who welcome you to this pyramid scheme game, and 10% paid up, and corresponding to who, for example, Ru and got the $20 from, let's say this is Nisa, right? And this is the Anna, right? For example, and Ru got $20 from here, and also got $20 from here. But for each the Ru recruit new person, Ru has to pay 10% from the new member. So 2 to Trump, right? So corresponding to, let me use different color. So Nisa paid $25, and this Anna also paid $20. And this $20, Ru got it, and they will keep some in their pocket. But for each this guy, they will pay 10%. They will give 10% to Trump, and also another 10% to Trump because it held new 2%. And such that you can see, in this case, so they left 45 in his hand, right? And this guy, they, based on the new join, and this one get $5 plus, right? Get $5. And so such that, let's say this is a plus $5. And you can imagine for every this new guy join, and you will have the Trump will get the money from that, right? Every new guy here, so this is a plus 12.5, right? And also in this plot, we also show you, so if the new person 12, and joined in this pyramid scheme, it will pay $25. And once they pay $25, they will pay for the person line, and the person line, get 90% and they pay up 10% to the upper person. And upper person, based on what they get, and they will pay 10% to the upper person, right? So it paid 0.25. Okay, good. Now this is what the tree look like after person line, recruit. And this is the previous money they do have. And after this payback, and you can see the money increase in the person one, right? Once you have all the load implemented, you will be able to run the simulation, play around with the prices, and see what happens with the pyramid scheme. In this simulation, we always end by collapsing the pyramid scheme, then the people at the top end up in a lot of trouble. Okay, so we ask you to download the DS assignment 4.zip. When you download it and unzip it, let's check. Okay, so when you unzip it, you may find out the DS library, right? In the library, this folder. And then so after that, it is in the specific SRC folder, and they have a subfolder, and this is the specific code related to we wanted to implement. And in the in the library, which already include the multi-tree node. Okay, so and then so download the tree ADT and copy it into the ADT package of the source folder, and download the multi-tree node Java, copy it into the data structure package of the source folder of the DS library packaging, and which corresponded to okay. Clean and rebuild the DS library packaging in the NetBeans. Import the DS library project into NetBeans. Right-click the project in NetBeans and tap the properties. Remove add some source project. I see. So for this part,